Okay, let's take a look at the system of inequality. Let's recall what is the inequality symbol. It will be greater than, less than, greater than or equal to, less than or equal to. Before we take a look at the system of inequality, let's recall how we graph just one linear inequality. So to graph an inequality, let me start it with an example. Let's see. Let's graph the negative x plus 2y greater than 6. For this is linear, because it's linear equation here and inequality sign. Usually the first place, we are going to graph the boundary line. The way we find the boundary line is going to replace the inequality symbol with equal sign. So you get a linear equations and then graph the corresponding linear equation. So this is the boundary line we are talking about. In this boundary line, if we have greater than or equal to, less than or equal to, that indicating we are including the points on the line, so we will use the solid line. If we have without the equal sign, then we are going to use the dashed line, then indicating we are not going to include the points on the line as your part solutions. Coming back to our example. If I change the inequality symbol to equal sign, then our boundary line will be negative x plus 2y equals 6. Just like graphing the other equations, we're going to graph these linear equations with the dashed line because it's not including the point. Okay, you can use the two intercept format to find the points x. If x equals 0, then y will be 3. If y equals 0, x will be negative 6. I'm just going to locate the 2 points. Here's negative 6, 1 point. Another point is 0, 3. I'm going to connect these 2 points with dashed line. So that is the boundary line we are looking for. Well, we are not done yet because this is only the boundary line. How about what other solution for this inequality? We must need to find the points which satisfy this inequality. The way we do is, well, you need to choose a test point. Well, this point cannot be on the boundary line. After you choose a point, you are going to substitute the coordinates of this point into the inequality. Well, when you substitute that, you might run into different situations. So the conclusion is if you get a true statement, then you are going to shade the half include or contains the test point, which is they are the solutions of the inequality. Or if you arrive to a false statement, then you are going to shade the other half. Okay, now let's come back to our problems. The origin 0, 0 is always my favorite test point if it is not on the boundary line. In the graph, I can clearly to see 0, 0 is not on the boundary line. So I'm going to test 0, 0. Put that into the original inequality, negative 0 plus 2 times 0 greater than 6. From here, I'm arriving 0 greater than 6, which is a false statement. Therefore, I'm going to shade the part without this test point, which is this half of the plane, is my solution. You can see our solution is represented on the graph. This is linear inequality. For any inequality, the idea will be the same, but instead of graphing a linear equation, you might just need to graph a nonlinear equation. For instance, what I'm trying to say is graph an inequality. Let's graph this one, which is we have y is greater than or equal to x squared plus 3. Similar idea. The first step, we are going to find our boundary line, which is switching the inequality symbol to equal sign. Since we have the equals in the inequality, so my line, I know that will be a solid line. Alright, let's take a look. This is a problem. It's the parent function y equal x squared shifted up 3 units, which is the vertex it's going to locate at 0, 3, right? And you can choose another point when x equal to 1, then y will be 4. X equal to negative 1, y will be equals to 4 as well. So that's the vertex 3. And when x equal to negative 1 or 1, y will be equals to 4. Okay. Connect those points. More or less, your parabola is open upward because the leading coefficient is positive. Solid line. So y equals x squared plus 3. And you can see this parabola divided the plane into two halves, a little bit different from the linear. It's no longer left or right or up or down. The half is inside the parabola or outside the parabola. You can choose some point inside here or outside here. Let me still choosing the point 0, 0. So I'm going to use the test point. Okay. So my test point is 0, 0. Because it's not in the boundary line, I can use it. Put that into my inequality is at 0 greater than or equal to 0 squared plus 3. And from here, I got 0 greater than or equal to 3. Again, it's a false statement, which means the half of the plane, which is outside of the parabola, is not going to be true. So this truest solution is this part in the problem. So that is solution step. Now let's take a look at the system of inequality, which means you are going to put several inequality together. It doesn't have to be two. The way it works is very similar, but instead of graphing one inequality, you will graph several inequality into one XY system and make sure the region you are going to shade is satisfied all the inequalities in your system. Let me start it with this example. Graph the solution set of this system, which is given x minus y less than 1, 2x plus 3y greater than or equal to 12. There are different ways to do the problem. Let's see. If I name this is 1, 2, I'm going to graph the inequality 1 first. Okay. Inequality 1, the boundary line is x minus y equals 1 with dashed line. I'm going to grab that. Let me get another piece of paper to grab on here. So x, y, to grab x minus y equals 1. So when y equals 0, x equal to 1. When x equals 0, y equals negative 1. Okay. So the first one, I'm going to use blue color. That will be this line. This is x minus y equals 1. And you can see, you can continue testing. Okay, so we are going to test a point. Here I notice that the origin is still not on the boundary line. I can use 0, 0. Let's see. It's a 0 minus 0 less than 1. 0 less than 1. Yes, it's a true statement. Then I can shade the part, the half of the plate, including the test point, which is 0, 0. So that is my solution of 1. The blue one is solution for the first inequality. And I'm going to grab the second inequality. Second inequality, again, starting from the boundary line. The boundary line is 2x plus 3y equals 12. And this is solid line because the inequality contains the equal sign. Alright, to grab this line, the same thing. You can find you can use slow intercept or any other points, and I usually like to use the intercept to grab the line. If x equals 0, 3y equals to 12, so y will be 4. If y equals 0, 2x equals 12, so x will be 6. Let me find these 2 points. Let's see. It seems I did not plan that really well. Let's see. 6, 2, 3, 4, 5. Oops. Yep. Let me extend the axis. 6 is right here. So that's 1 point. Another point is when y equals 4. Okay, that's y equal to 4. Connect these 2 points with a solid line. So that is our inequality boundary. 2x plus 3y equals 12. Again, you can use different test point. Maybe I still use test point 0, 0. It's a 2 times 0 plus 3 times 0 greater than or equal to 12. From here, I got a statement 0 greater than or equal to 12. So it's a false statement, which means I'm going to shade the part without including the test point will be the other half. So that will be, this is the solution for inequality 2. Since in the problem you are looking for the solution of the entire system, which you are looking for the set of solutions satisfy both inequality, the one you overlap with each other, which is in this upper corner and here, that will be the solutions of the system of inequality we are looking for. So this is your solution set. Also, you can just grab the system of inequality closed boundary, and then you will divide into 1, 2, 3, 4 region, and you can test each region, and you will draw your conclusion that will be similar. This is a system of two linear inequality. Let's take a look at a system of some nonlinear inequality. Let's see. We are going to continue graph the solution set of the inequality, which have nonlinear one, is y greater than or equal to x squared minus 4, x minus y greater than or equal to 2. Similar. Let me call this equation 1, inequality 1, inequality 2. And this time I'm not going to grab one by one. I'm going to grab both together. What I meant is I'm going to grab the boundary line of 1 and 2. So for the boundary lines for 1, let me use blue color, is y equals x squared minus 4. It is a solid line. Okay, let's see what I can get from here. Okay. So it's a quadratic equation, so it's a parabola open upward with the vertex located at -4. And if y equals 0, x will be positive -2. So you have these 2 points. Okay, again, it's a solid line, parabola open upward. Okay, this is y equals x squared minus 4. The second inequality we have, the boundary line is x minus y equals 2. Also is a solid line because we have the equal sign right here. X equal to 0, y will be -2. Y equals 0, x will be 2. That's the second boundary line. Then you can see these two boundary lines divide the entire plane into regions bounded by this part above this line, or in between them, this little corner, or outside here above, or below. Okay, so you can choose some text point in this area, and this area to test that. For instance, again, I got 0, 0 to test. Then I have 0 greater than or equal to 0 squared minus 4. That's a true statement, which is satisfied. Oh, let me call this A. So true for the first inequality. But how about the second inequality? Is it 0 minus 0 greater than or equal to? That's false for the second inequality. Then this whole region, including the 0, 0, is not the solution of the whole system, even though it is a solution for the first inequality. Now let me get down here to test a point. Okay. Test maybe this point, that will be -3, right? 0, -3. Let's take a look. The first inequality is at -3 greater than or equal to 0 squared minus 4. Yeah, true. So it satisfies the first inequality. How about second inequality? 0 minus -3 is that greater than or equal to 2. So we have 3 greater than or equal to 2. Yes, both statements are true. That means my solutions should be in the region I'm testing right here. So that's my solution set. Okay, so that's another way to check which region is our solution by just grab all your boundary lines, and then the boundary lines are going to divide the plane into different regions, and you're just going to check what happened to each region. Alright, I think we still have time to take a look at one more example. Let's take a look at this one. We are going to grab the solution set of this inequality. I'm going to put down 3 of them. X plus y less than or equal to 4, y greater than or equal to 2, x greater than or equal to 0. So I have 3 inequalities. Let me do that one by one. Now I'm going to grab the first one. The first one, the boundary line is changing the inequality symbol to equal sign. X plus y equals 4 with a solid line. Alright. I'm going to use black for this part. X and y axis. And when x equals to 0, y equals 4. So that's the point. When y equals 0, x also equal to 4. It's a solid line, right? Because it's the equal sign. I'm going to test. Right? I'm going to test, my favorite point is 0, 0 because it's not in the boundary line. I can use that. So is a 0 plus 0 less than or equal to 4? True. Then everything on this half plane, including the 0, 0, is the solution for inequality 1. Let's take a look at inequality 2. Let me use blue color. Again, starting from the boundary line. The boundary line is y equals 2, which is solid line again. Alright, y equals 2 is constant, so that is a horizontal line, the line passing the point 0, 2 right here. So horizontal line, solid line. This is line y equals 2. So horizontal line divided above or below. It seems like 0, 0 is not on the boundary line. Again, I can still use the 0, 0 to test that. Is it 0? Y equals 0 greater than or equal to 2? No. It's a false statement. That means my solution, I have to shade the part without the testing point, which is the part is above the horizontal line. So this part is your inequality 2 solution set. And the third one, the boundary line will be changing the inequality symbol to equal sign. That will be x equals 0. Oh, that is my y-axis and with solid line again. So that's x equals 0. And this time I cannot use 0, 0 again since 0, 0 is on the boundary line. Let me choose any other point test. First I want to choose, let's say just this point. That point is 3, 0. Is that 3 greater than or equal to 0? Yes, that's true statement. Then we are going to shade the half of the plane, including 3, 0, that point. So it will be on this side. So everything on this side is my solution for the third inequality. So the red part is your third inequality. And take a look, which part we overlap had 3 colors, black, blue, and red. And will be this little triangle right here. So that little triangle is our solution set. That is our solution set for this inequality. Okay, I hope it helps you to understand how to solve the system of inequality. Basically, we are graphing, using graphing method, graph the boundary line and choose test point to test if it satisfies the condition or not. If it satisfies the whole region, includes the boundary, include the test point will be the solution set. See you next time.